Okay, what you're going to do is, okay, go into Google Classroom. I just posted it, so if you were signed in like more than a couple minutes ago, it won't be there, but okay. So if you click on Science 10 Period 1, okay, you'll see that I posted a new assignment, Properties of Compounds Lab. Okay, just click on that, or you can access it through the Class Work tab as well. Okay, it's right there. Okay, also guys, green indicates obviously that it's not done, okay, that you haven't turned it in yet. All right, so when you open this up, you're going to see this, okay? You're going to see a PDF document. That's the lab sheet that I'll have up on the board, okay? It's basically the same as yours. It's got a few more things in it, all right? You'll also see 3 videos, okay? One's pre-lab. That's what we're going to do right now. It's what I'm recording right now. I'm going to replace this one, okay? There's also going to be one that is about the analysis and conclusion, which we'll talk about tomorrow, and I'll record that, okay? And then there's also an observations video, okay? That is there for 2 reasons. Maybe you're sick tomorrow and you missed the lab, okay? If you are, you can watch that video and you'll get the same data everybody else got when they were here. Second reason it's there, maybe your group messes up, okay? Maybe we run out of time, or maybe you're just not really confident in the data you got, and you just want to double check and make sure it's right, okay? You watch that video, okay, and you'll basically see me during COVID, well, except I don't really film my face, just my hands, okay, doing the lab and getting the data so that you can put it in, okay, and record your observations from there. So it's there, you can use it or not use it. If you're here tomorrow, you probably won't need it. Okay? All right, and then below that, you'll see your work. Okay, and in there is a Google Doc that has your name on it. That is your lab report document. That document and only that document gets turned into me. Okay? Don't try and attach some other file. I won't accept it. Okay? The reason being, in this file, I can track your work. That probably seems creepy, and it's meant to be. Okay? I can see when you did your work and what you did. In other words, I know if you copied it or not. Okay? If you submit something else, a PDF, pages, whatever, I'm not even going to look at it. It has to be in this document. Okay? Everybody clear there? All right. So have that open. You're going to be typing in that document as we go along here. Okay, so it's going to look like this. Okay, you're going to put the problem in your own words. You're going to fill in your manipulated, responding, controlled variables. Hypothesis is there, reminding you it needs to be if, and then. Okay, we've got the materials here. There's a procedure. Okay, I would recommend for tomorrow that either you have that procedure printed to follow, okay, so that you can follow it in the lab, or we'll see about possibly having one member of each group having a phone so that they can bring it up. Okay, we'll see, but I prefer that was on paper for tomorrow, okay, because you just never know in the lab, things happen, stuff gets damaged. That's why we don't take the Chromebooks across the hall to the lab. Okay. All right, everybody there? Everybody got their document open? Let's talk about that particular document. All right, so the problem, and remember this one, okay, like I said, you can copy and put in your own words the problem that I have here, okay? In this lab, we're trying to find out if it's possible to identify a bunch of unknown compounds using only their physical properties, okay? That's what we're trying to investigate. That is our problem. Can unknown compounds be identified with their physical properties alone? Okay, so there's a problem up there. You can copy that, put it your own little spin on it. Okay, that's what I'm looking for the problem. The problem isn't worth any marks, but there has to be something there. Okay. For our variables, okay, this is our next step here, our design part. Right, here's how the lab is going to go. From my description and my gigantic hints that I'm going to drop while we're doing this, okay, I want you to kind of pick out what the manipulated variable will be, what the responding variable will be, and what some of the controlled variables are for this experiment. Okay, so in this experiment, we're going to have our 11 unknowns. Okay? What we're trying to do is run some tests on each one of them in order to figure out what their identity is. Okay? So, we're going to run the same tests on each unknown variable. So every time I run a set of tests, I'm running it on a different material. Almost like I'm manipulating what material I might be working with. Subtle, right? Obviously, the reason I'm doing that is because the premise of this experiment is that all of those unknown materials that I'm manipulating will have different physical properties. In other words, every time I test a substance, should the results of the tests be different? In other words, they might respond to what I was testing, those results, right? They might respond to what I tested. Okay. And just so you know, guys, when we do pre-labs for subsequent labs, you won't get this much time you'll get enough time to like make a quick note, but I won't give you this much time to write out the whole thing. This is just our first lab, so I'm giving you that extra time. Okay, but I'll go through this process a lot faster, okay, on other labs. Now, the way this experiment's going to work is you're going to get a depression plate. Okay, this is a depression plate. Okay, it's not going to make you sad. Okay? It just has little pits in it for you to do your experiment in. Okay, so what we're going to do, by the way, I'm going to start giving you some of the controlled variables if you listen carefully here. Okay, I'm going to make sure that I just cover the bottom of these depressions with each material. So in other words, I'm going to use exactly the same amount of each material for these tests. Okay. While you're typing that, you might want to think about why that would be important as part of your explanation. Okay, that part I'm not going to give you. I'm going to make you figure that part out. Okay, why would it be important to make sure I use the same amount of materials for all of these tests? Okay, something we didn't talk about before, okay, is that controlled variables generally fall into two categories. Okay, there are what we call procedural controlled variables. Okay, those are things that we make sure we do the same throughout the experiment. Okay, and then there are conditional or sometimes environmental controlled variables. Okay, those are things that are, as best as we can, kept the same for the environment in which the experiment is being conducted. So next thing, okay, so we've already said we want to make sure that we have the same amount, that we use the same amount of these things. Okay, the next thing would be that they're all tested the same way. The same tests need to be run on all of these so that there's comparable data. Okay? If I only run 2 tests on one material and I run 3 different tests on another one, I really don't have comparable data. Okay? I would say that's also a procedural controlled variable. Okay? Give you a minute on that one. Okay, so an environmental or conditional variable that would stay the same in the lab tomorrow during the experiment. Okay, you tell me what it is, okay, why it needs to stay the same, and how it's staying the same. Okay, and that can be as simple as it's just not going to change because we're indoors or whatever. Okay, in the control variables. So normally in a lab, what I'm looking for from you is a mix of procedural and environmental controlled variables. Okay, so 2 of one, 1 of the other. Doesn't matter which one you have 2 of and which one you have 1 of, okay, but you should have a mix. Okay, don't just have 3 environmental ones, okay, or 3 procedural ones. Try and have a mix of both in there, okay, because that tells me you're paying attention to not just instructions, but also conditions. Okay, are there any questions on the variables? Okay, hopefully you guys have got, you know, a fair amount of stuff typed there already. Okay, that's what I would be looking for. Okay, the next thing we want to do here is our hypothesis. Okay, our hypothesis, remember, is an if and then statement. Okay, that is going to talk about the premise we're working on. Okay, for this lab, the only way we can identify all those unknowns is if they all have different physical properties. Okay, that's the only way that this lab works. Okay, I can't identify them any other way. They have to all have different physical properties. Right? We're going to test them by running the same battery of tests. Okay, the same battery of tests on all of them. Okay. And then recording our results. Okay. And what we should get at the end of that then is a unique data set for each one. If you were really paying attention there, I just absolutely gave you the entire thing. Okay, so let's quickly do that again here. The if part of your hypothesis is the idea that you are working on, or the premise that you are working on. For us in this lab, okay, all compounds have unique physical properties. Right? If I don't get different test results for every one of these, how am I supposed to tell them apart? Okay, would you agree? Okay, so in the if part, okay, you want to talk about physical properties, unique physical properties. So, okay, I'm just doing a brief thing here. You have to put this in your own words. Okay, this idea that all compounds have unique physical properties. Now, as we said before when we were talking about format here, the and part of your hypothesis is a brief description of the experiment you're going to run. All right? For us, we're going to run kind of a battery or a series of tests to find the physical properties of each compound. Okay? You don't have to be more specific than that. Okay? That's what the procedure is for. Right? But a series of tests to find physical properties is being done to each unknown compound. Okay? Again, that goes in your own words, but the gist of it is, okay, tests are being run to find physical properties. Okay? That's the gist of it. Last part of the hypothesis, the then part. Okay? This is where you predict your findings or predict your results. Okay? So I'm going to kind of say this one more time so that you can get the idea of what you might get here as a result. Okay? We're working on the premise that all things have unique physical properties. we're running tests to find those physical properties. So if everything has unique physical properties and I run these tests, then what should I see? What are my results going to be? Okay. Will I get different observations for every single one of them? And what were those observations again? We're observing their physical properties. Okay. Find a way to put that in your own words in the then part. You're predicting your findings. Okay? If all substances have unique physical properties and we do this, then the results will be this. The last part of that, you've predicted what your results are going to be. The last part of this should be, what can you do with those? Okay? So if your results are that every unknown compound had a unique set of data or had different results, okay, or displayed different physical properties, what can you do with that? Think back to the problem. What were we trying to do with these unknowns? Now we have their physical properties. What can we use those physical properties to do? Okay, that should be the end of your then part. Okay, so now down below your hypothesis, you'll see the list of materials. Okay, so on your sheet, okay, it looks like this, right? In that list of materials are the identities of the unknown compounds. Okay, so that means that one of the compounds is ammonium nitrate. One of the compounds is copper 2 sulfate. One of them is ethanol. Okay, one of them is paraffin. Okay, that's candle wax. Okay, one of them is sodium chloride, table salt. One of them is sodium hydroxide, that's stuff that's in oven cleaner. Okay, one of them is hydrogen chloride. One of them is sucrose or table sugar. Okay, one is water. One is cobalt 2 chloride. One is nickel 2 chloride. Okay. So you've got your possible identities there. What you'll have to do after tomorrow, when you have all of your data, is you'll have to figure out, is B sodium hydroxide, is C paraffin, blah, blah, blah. You just have to identify. Okay? So you take your physical properties, you go, okay, well, that one conducted electricity, so it has to be an ionic compound, so it can't be paraffin. Okay? And you kind of just have to work it down from there. Okay, everyone kind of follow? That's why we went over all those properties in class yesterday, because that will help you, once you have your data, to figure out what's what. Okay, some of them will be really easy. You'll get them right away. Okay, probably the colored ones, right? Probably the easiest ones. But there'll be some others that you'll probably be able to figure out pretty quick. Okay, some of them you'll have to work at. Probably the last one will be process of elimination. Okay, well that's only got one left. It's got to be this stuff then. Okay, that's okay. And it's absolutely okay tomorrow to go home and Google the physical properties of every single one of those. Okay? Nothing wrong with that. Okay? You have the physical properties there, then you're still doing the process I want. Okay? Oh, that's an ionic compound that's going to be blue in color and highly soluble. Nope, I got one that says that. Okay? That's totally fine. That's the process I want you to go through. Okay? Everybody with me so far? Okay. So the procedure's pretty straightforward, okay? You're gonna get your depression plate. So everything will be at the front, okay? Probably on a cart, okay? Each group will need one depression plate. That's one of these, okay? Somebody has kindly written on these already A, B, C, D, E, F, okay? Well, obviously, you're gonna have another set here of 5 after that. So you just have to keep track of what you're putting in each depression, okay? The other thing you have to be really careful of, don't get any of A in B. Will that affect your results? Yeah, it will. So you got to be really careful about that. Okay, watch carefully for cross-contamination. If that happens, then just make sure you don't use whichever one was contaminated. Do all the other ones, dump them out, and do that one again. Okay, come and get a fresh sample. It's okay. That's going to happen in the lab. Okay, as long as you're not coming up 7 different times. Okay, be careful. You can. Okay, so you'll get those and you'll just cover the bottom of the depression plate with the unknown stuff. Okay, so collect the depression plate, you're going to get a thermometer, a stirring rod, a conductivity apparatus, and pH strips. I didn't bring the thermometer in because I figure you guys probably know what those look like. Okay, this is the conductivity meter. Okay, it's exactly as I described it yesterday. It's a black box with a 9-volt battery on top and 2 leads coming off the bottom. Okay, very simple. There's a button on the side. You press the button and the little red light comes on indicating that it's working. Okay, our previous models didn't have that, and so you just didn't know if it wasn't conductive or the battery was dead. So at least this tells you, hey, it's working. Okay, and then you stick it in a solution and it'll give you a reading from 1 to 10 of conductivity. All right, less than 5, that's basically non-conductive. You're probably looking at a molecular compound. Okay, 5 or higher. Okay, you're going to get, that's good conductivity, and you're looking at an ionic compound. You're probably not going to get many readings that are in the middle. You're going to get 1s, 2s, and 3s, and you're going to get 7, 8, 9, 10. Okay, you probably shouldn't get too many readings in the middle. Questions on that? Okay, and you'll also have pH strips. Okay, that's these things here. They come in a little plastic vial, and they have the color code on the side. So you take them out, they're orange in color. All right, I would say 1 strip will do 2 samples. Just take it off, rip it in half. Okay, put it in the solution, and then you compare the color here. And that will tell you the pH, and then record that. Okay, so those are pieces of equipment. I don't know if you've seen them before, but that's what they look like. Okay, a lab scoop. We have a bunch of different lab scoops. I won't use any of these. These are frightening. They look like a prison shank. I don't know, they just bother me at the look of them. Okay, I'll give you different ones for these that work better than this one does. But we'll have scoops, okay? And there will be a scoop in each one of these. Use that scoop for that one only. Okay, don't go, this is my scoop, and put it in every single one, because what have you just done? Contaminated them all. Okay, so each one has a scoop, or if it's a liquid, it'll have an eyedropper. Okay, use what's in it. If there isn't one in it at the time, be patient, it'll be back. Okay. All right, so we said here, take equal amounts, 1 gram. It's going to just cover the bottom. That's what we're going to say, because if we're taking the mass for every one of these, this takes like 3 class days. It's not worth it. Okay, so we're just going to cover the bottom. Okay, we're going to label it. Okay, those are probably already labeled. Okay, and then step 3 is our first test. Okay, you can actually see that down here, there's a chart for you to record your data in, right? And the biggest one is labeled observable properties. That's basically have a look at it and record anything that you can observe at that point. Okay, that is color, state, texture. Okay, anything else that you think is important, okay, that needs to be recorded there. Okay, that make sense? Okay, for observable properties? Okay, whatever you think is important. Okay, so in here, okay, it says, okay, color, texture, is it crystalline? Because obviously that could mean it's ionic. Waxy, molten, okay, so it's like kind of coming apart. State of matter, is it solid, liquid, or gas? Waft the samples, okay, see if any of them have an odor. Here would be my suggestion for that. Waft the sample at the front. Okay, if you have them all in your depression plate and you're going like this, are you smelling all of them? Okay, so smell the big sample at the front. Okay, okay, record any odors and any other characteristics you feel are important. So you do that for all 6 that you have in the plate. Then, you'll run the solubility test. Every group will have a little squeeze bottle of water. They have distilled water. What you will do is squeeze some of that into the depression while doing 2 things. You will have a thermometer in the depression, okay, as you add the water. And you will have another group member who is stirring. Okay, so it's like a 3-person job. The thermometer person, the stirring person, and the water adding person. Okay, so group size here is minimum 3. Okay, We don't want to go any smaller than 3 because we don't have enough lab stations. Okay, I'm saying probably tomorrow groups are going to be like 4 or 5. Okay, just make sure everyone's included. I'll let you pick your groups. You got to make sure everybody's included. Okay, so you'll do that and you'll record. Are there any temperature changes? Okay, you record that. Okay, starting temperature was 20, now it's 35. Okay, well I record that as a temperature change. Okay, during the solubility test. All right, and then basically after stirring it, give it a minute. You don't need to keep stirring it for 5 minutes. It'll take too long. If it doesn't dissolve significantly in a minute, then it's not soluble. Now, realistically, are you going to get all of it to dissolve in that tiny little amount of water? Okay, so what are some signs you can look for to decide whether it's soluble or not? Like, will some of it dissolve? Will it look like there's less of it? Okay, when crystalline things dissolve, do they tend to shrink and the edges get softer, rounder? Right, like if you dissolve salt, it doesn't look quite as, right? You kind of know what dissolving looks like. Make your observations, record those. You're probably not going to get everything to dissolve for all of them, but that doesn't mean they're not soluble. Okay, if it changes color, assumes the color of the salt, that's a sign that it's dissolved. Okay, those are things to look for. Okay, so number 4, using an eyedropper containing distilled water, it'll be your squeeze bottle. Fill the depression to within 3/4 of full. Is that making sure we use the same amount of water every time? Probably important, right? Okay, and take the temperature of the mixture, record if it's soluble based on color changes, changes in crystal shape, etc. Rinse the thermometer between tests. Why is that important? Exactly. There's going to be stuff on that thermometer. If you just take it from one to the next, you're contaminating the next one. Right? Just take your wash bottle and just spray off the thermometer a little bit, okay, and then go to the next one. You need to make sure you rinse each time. Okay? That's kind of important. And rinse with the bottle. Why not tap water?
Because it's not distilled water.
Right? Will it have ions in it? Could that affect your conductivity test? And that's the next test. Once you've done the solubility test, okay, now you have a solution of that material. Okay, now you take your conductivity tester, plop it in there, and record the number on the face. Pretty easy. Okay, once that test is done, take a piece of pH paper, plop it in the solution, record the number. Okay, making sense? And then we'll have our data. And tomorrow, when we've collected all of our data, we will talk about the analysis and the conclusion. We won't have the Chromebooks tomorrow, so you might have to take some paper notes tomorrow. Okay? All right. Now, make sure that your Chromebook is signed out, shut down before you close the lid. Then it comes up here and it goes in the correctly numbered slot and gets plugged in. Thank you.